A modern aircraft carrier is a massive warship. It looks like a small city floating on the ocean. These ships are very long, often stretching over 1,000 feet. Their most prominent feature is a large, flat deck. This deck is a runway at sea. Powerful jets, other aircraft stand prepared on this surface. The United States Navy uses these incredible vessels to project power across the globe. They allow advanced aircraft to operate far from home, near potential trouble spots, with incredible speed and efficiency. This essay will explain the intricate process of how the Navy launches these superjets from a huge ship, detailing the launch path in clear, simple terms. Understanding this process is important. The flight deck of an aircraft carrier is one of the most dangerous workplaces on Earth. It is a scene of constant, organized chaos. The crew members who work here wear colored jerseys. Yellow shirts belong to the aircraft directors, who guide the planes on the deck. Green shirts are for the crew who handle the catapult and arresting gear. Blue shirts are for the plane handlers who move and secure the aircraft. Purple shirts, known as grapes, handle the fueling of the jets. This color-coded system allows for quick visual identification and clear communication amidst the deafening roar of jet engines. Before a plane is cleared for launch, it undergoes numerous checks. The crew on the deck performs a final inspection. They check for any signs of damage or leaks. They ensure the engines are running correctly, and that all control surfaces are responding as they should. The plane must be perfectly aligned and securely attached to the catapult shuttle, or positioned correctly for a ski jump launch, or set up for a vertical takeoff. The fundamental challenge of launching a jet from a carrier is speed. A runway on land can be thousands of feet long, giving a plane plenty of room to accelerate. A carrier's flight deck is much shorter. To solve this, most large carriers use a catapult system. The traditional system uses steam. High-pressure steam is stored in accumulators below the flight deck. When it is time to launch, this steam is released into long cylinders that run beneath the catapult track. The immense pressure drives a piston forward at incredible speed. This piston is connected to a shuttle that sits in a track on the flight deck. The nose gear of the aircraft is attached to this shuttle. A holdback bar keeps the aircraft in place as the pilot increases the engine power to full afterburner. When the launch officer gives the signal, the holdback bar releases, and the steam catapult fires. The system yanks the aircraft from a standstill to over 150 miles per hour in just 2 seconds. This tremendous acceleration provides the necessary airspeed for the wings to generate lift. The pilot pulls back on the control stick as the plane leaves the deck, and it climbs into the sky. This powerful, violent process has been the standard for decades. The newest American aircraft carriers, starting with the USS Gerald R. Ford, have replaced steam catapults with a revolutionary new technology. It's called the Electromagnetic Aircraft Launch System, EMALS. Instead of steam, EMALS uses a powerful linear induction motor. Linear induction motors under the flight deck. The same basic tech powers some high-speed maglev trains. A massive electrical pulse runs through electromagnets along the catapult track. That pulse creates a magnetic field which propels the shuttle and attached aircraft down the deck at incredible speed. EMALS offers several key advantages over steam. It's much smoother. It provides a more constant rate of acceleration. That puts less stress on the aircraft airframe, reducing wear and tear, so planes can fly more missions before major maintenance. It's far more precise. Launch officers can dial in the exact force needed for a specific aircraft at a specific weight. That precision makes launches safer and more efficient for heavy aircraft, light aircraft, and future unmanned drones. The launch path of a carrier aircraft begins long before the engines roar to full power. It starts with the plane being moved from its parking spot to one of the catapults. The yellow-shirted aircraft directors use a series of precise hand signals to guide the pilot. Once the aircraft is in position, the green-shirted crew connects the nose gear to the catapult shuttle and attaches the holdback bar. The pilot and the deck crew perform their final pre-launch checks. The jet blast deflector, a massive steel plate, rises from the deck behind the aircraft to protect other planes and crew from the intense heat and force of the engine exhaust. With all checks complete, the pilot signals they are ready. The pilot pushes the throttles to full power and the engines scream as the afterburners ignite. For a few moments, the plane strains against the holdback bar, a chained beast ready to be unleashed. The catapult officer, known as the shooter, watches the gauges to ensure the engines are producing enough thrust. When everything is perfect, the shooter touches the deck, giving the signal to the console operator. The operator presses the launch button. The holdback bar breaks away, and the catapult fires, rocketing the jet down the track. The acceleration is immense, pushing the pilot deep into their seat. Two of the most critical factors in any aircraft launch are wind weight. Lift, the force that makes an airplane fly, is generated by air moving over the wings. The faster the air moves, the more lift is created. An aircraft carrier can create its own wind to help with this. The ship's captain will turn the vessel to steam into the natural wind. This is known as setting the wind over deck. Natural wind, 20 knots. Ship speed, 30 knots. Total wind over the flight deck, 50 knots. This manufactured wind is a huge advantage. An aircraft sitting on the deck already has 50 knots of airspeed before it even starts moving. This means the catapult system does not have to work as hard to get the plane to its final takeoff speed. A higher wind over deck allows aircraft to be launched with more weight, meaning more fuel or more weapons. The ship's captain, the air boss in the tower, and the launch officers all monitor the wind speed and direction constantly. Not all carrier aircraft require a long runway or a powerful catapult. A special class of aircraft is capable of vertical takeoff or short takeoff and landing, often abbreviated VSTOL. The most famous example in the US military is the F-35B Lightning II used by the Marine Corps. This advanced jet has a unique propulsion system. Its main engine nozzle can swivel downwards to direct thrust vertically. A powerful lift fan behind the cockpit engages to provide additional upward force. This allows the plane to lift straight up off the deck like a helicopter. This capability is incredibly useful. It means the aircraft can operate from ships with much shorter flight decks, such as amphibious assault ships, which lack catapults or arresting gear. The launch path for a vertical takeoff is completely different. The pilot positions the aircraft on a designated spot on the deck. On command, the pilot engages the lift system and the plane rises vertically into the air. Once it has gained some altitude, the pilot begins the transition to forward flight by slowly rotating the engine nozzle backwards, then disengaging the lift fan. The plane accelerates forward and flies away like a conventional aircraft. More commonly, these aircraft perform a short takeoff. Instead of lifting straight up, the pilot uses a short, rolling start. The engine nozzle is partially angled down, providing both upward lift and forward thrust. Combined with aerodynamic lift from the wings, the jet becomes airborne after a very short run, often less than 500 feet. Many ships that operate VSTOL aircraft, including British ships and Italian ships, also incorporate a ski jump ramp. The short roll plus ski jump lets the F-35B take off with heavier fuel and weapons than a pure vertical launch would allow. This flexibility makes VSTOL aircraft a powerful asset. They bring supersonic fighter capability to more naval vessels. The launch process is less mechanically complex than a catapult launch, but demands immense pilot skill to manage the vertical to horizontal transition. The launch path is a gentle climb upwards and forwards in stark contrast to the violent horizontal acceleration of a catapult shot. It represents a different but equally effective solution to operating powerful jets from the sea. On the chaotic and hazardous flight deck of an aircraft carrier, safety is the highest priority. Every procedure, every piece of equipment, every crew member's role is designed with safety in mind. The deck is loud, so verbal communication is often impossible. The crew relies on a standardized set of hand signals to communicate clearly and instantly. At night, they use lighted wands. This visual language ensures that everyone, from the pilot to the plane handlers, understands what is happening at all times. Radio communication is also used, but the hand signals provide a reliable backup. Fire is a constant danger. The aircraft are loaded with thousands of pounds of jet fuel, and their engines produce incredible heat. A dedicated team of firefighters, wearing heavy silver proximity suits, stands ready during every launch and recovery. They are part of the crash and salvage crew, and they are trained to respond instantly to any emergency. Firefighting stations are located all around the deck. The deck has a foam suppression system that can quickly smother a fuel fire. In summary, the launch of a superjet from a massive warship is simple in concept, but incredibly complex in execution. It begins with meticulous checks on the flight deck, where a color-coded crew ensures the aircraft is perfectly prepared. The ship turns into the wind. A powerful launch system provides the critical burst: steam catapult, electromagnetic EMALS, ski jump ramp. The aircraft accelerates with tremendous force. It lifts off the deck, then follows a planned climb and clearing turn. The flight path keeps the aircraft, the pilot, and the ship safe. It clears the way for the next launch. The operation is overseen by highly trained officers and crew. Safety teams stand ready for contingencies. Weight and launch power are precisely matched. Technology and human skill blend seamlessly. This capability makes the carrier a formidable instrument of national power. It projects air power anywhere, independent of foreign airfields. Strike missions, air defense of the fleet, surveillance. Rapid, safe launches are the foundation of the carrier's mission. A testament to decades of engineering innovation and the professionalism of sailors and aviators. The launch path is a tight dance of skill, speed, and massive machinery. Roaring engines, dedicated crew, powerful technology. When all parts work together, the aircraft lifts cleanly from the deck. The ship and its crew have done their job. The aircraft moves from sea into the wide blue sky, ready to complete its mission. It is a powerful and awe-inspiring display of modern naval aviation.